Hi, I'm Paul Battaglia, and this is section 7.7. Students come into section 7.7 with a vast knowledge of limits and derivatives and integrals, the three big ideas that we first cover. However, it's been a while since we looked at most of these things, specifically limits and derivatives. So if you're a Calculus AB teacher, remember that this section is new to the AP curriculum framework, and it will need to be covered. So the essential question we would like students to be able to answer at the end of section 7.7 is, how do I evaluate limits of various indeterminate forms? So since we're going back to limits, I think it's always best to maybe give the students a nice warm-up. And so what we'll do is we'll give them the limit as x approaches 0 of 1 minus cosine of x over sine of x. And I'm going to ask them to do this two ways. The first way is their choice, graphically or numerically. So if they like to use a table, they can certainly do that. Or if they just want to graph the function and try and determine the limit from there, that's okay. The second method will be analytical. Now that might be a problem for some students because they'd actually have to remember how to work with the conjugate. Because in this problem, they'd have to multiply by 1 plus cosine of x over 1 plus cosine of x. Now keep in mind, you and I know that we can use L'Hopital's rule for this problem. They don't know that yet. So I'm going to save that for later. And right now, I just want to dust off a little bit and make sure that they can review limits a little bit, and then from there, go into L'Hopital's rule. So what we'll do is we'll show them at first the rule and how we need to have a quotient of two functions, f of x, let's say, over g of x. And we need f of a to equal g of a and that to equal 0. We need that indeterminate form to show up. Now, in this case, we need students to kind of run through the examples a little bit so they can see how to work with L'Hopital's rule, taking the derivative of the top and the derivative of the bottom. And believe it or not, they actually need to watch out. And it's a little weird, but this actually might start to kind of remind them of a common error they made way back when they did the quotient rule, thinking that you could do the derivative of the top over the derivative of the bottom. And obviously that wasn't the case. So just watch out for that if for some reason you're doing multiple things at one time. But that being said, let's take a little bit more of a look at some other examples that might help students along. In example 3, we see the need for multiple iterations of L'Hopital's rule. But what should be pointed out to students is that we only need to do that if the previous step also yielded an indeterminate form. So for instance, I'll get the question sometimes where students will say, well, I did L'Hopital's rule, I got a limit, let's say it was 4, and I don't know why I just couldn't keep going. What's preventing me from continuing to do L'Hopital's rule again and again? And I always tell them, L'Hopital's rule is only useful if you're dealing with indeterminate form. So if you evaluated a limit and you got 4 as the answer, it's not indeterminate anymore. So in these cases, students should kind of look out for maybe doing too much. So just watch out for that. Now, example 4 is a great example of how we can use L'Hopital's rule to compare the relative rates of growth of two functions, say e to the x and square root of x. See, in these cases, it's important for students to understand that as the values of x get larger, using L'Hopital's rule actually helps us find out which functions grow faster. Now those two functions, it's not really hard to decipher. E to the x definitely grows faster. But through the limit process, students can ascertain whether or not the top is growing faster or the bottom is growing faster by whether or not we yield infinity as an answer or 0. Now, here are some ways that maybe you could finish up and help the students get ready for some more difficult assessments, maybe even the ones they might see on the AP exam. Remember the problem we warmed up with, we can now bring back and we can start a little closure by saying, okay, we already know this answer, but now try and run through that limit using L'Hopital's rule. An even better one might be to go back to a special trig limit that they saw way back when, sine of x over x. The limit as x approaches 0. Now they should know it's 1 because way back in chapter 1 we really asked them to memorize it. But if you remember, we may or may not have actually gone into the y. Now they can use L'Hopital's rule to see why that equals 1. And here's a fantastic way to end everything up. Exercise 115 does an awesome job of blending fundamental theorem of calculus part 2 with L'Hopital's rule. Always showing the students that we don't want to just be in the here and the now, we want to be able to connect something that we're doing now with what we've done previously. Here's what that problem looks like. It's a quotient, it's the limit as x approaches 2, and then in the numerator we see the integral from 2 to x of e to the 1/2 t dt. And on the bottom, we see x cubed minus 8. Not easy by any means. And for students to struggle with this would be completely normal. But what you're going to see is a lot of discussion. How we handle this. Hey, this looks very different than some of the other things I've seen. This is good. Gets them talking, gets them really used to seeing things in a different light, and really stretches their understanding of L'Hopital's rule. So I hope these tips have been helpful, and I'm sure you'll find much success with section 7.7.